Okay. So you have a battery of 20 volts. Okay. Then you have, this is 500 ohm, and then you have a Zener diode here. Okay, थोड़ा board wet है, so it may be light. So this is 1 kilo ohm, and then you have a normal diode, and then you have a, say, a 2 kilo ohm resistor. Okay. Now in the question says, yeah. So question says, a circuit shown in the figure, the voltage drop VL across the 2 kilo ohm resistor is. So what is the voltage drop across this 2 kilo ohm that we have to find out? Okay, this is a 20-volt battery. Okay, so what is the possibility here? I have Zener diode here. Okay, and then I have a normal diode. So first let us say we have to find which diode is conducting. Okay, the possibilities are, there are 4 possibilities that all the 2 diodes, okay, Zener diode has a voltage. How much voltage is required? It requires 10 volt to watt. So it is given 10 volt and 2 watts. Okay, and this normal diode requires 0.7 volt for turn off. So there are 4 possibility. Possibility number 1, both the diodes are off. Both the Zener as well as normal diode are off. Okay, both the diodes are off. Off matlab both are open. Second second is Zener is on. Zener diode. Okay, now I will write in short. I write JD, Zener diode. Second possibility is GD is on, GD on, and normal diode, ND is off. Okay, and so actually we have to see all the possibilities. This particular question is very simple, so we can find out. Okay, that both are on, but in general we have to check all the possibilities. Now Zener diode is on, and the third thing is Zener diode is off. Zener diode is off. Okay, and normal diode is on. You can also write diode 1, diode 2, and the fourth possibility is both are on. JD is on and ND is also on. This is the fourth possibility. Students, can you see my board properly? Is my board is visible to you?
No, sir. Sometimes the light comes in.
Yeah. But now, if I am the far away, can you see this one?
Yeah.
Okay. So this is 500 ohm, 1 kilo ohm, and 2 kilo ohm. Okay. So now, first possibility, I say both are off. Okay. First is both are off. Let us check if both can be both off. So if both are off, this will be off. Okay. No current will flow here. And this is, now you see, this normal diode just requires 0.7 volt. Okay. And if I apply, I'm suppose this is off. So it cannot happen that this is also off, because this requires only 0.7 volt and we have a 20 volt battery. So this 20 volt battery is making this Zener diode, this normal diode on. So the assumption that both diodes are off is not correct. Okay, both diode cannot be off. Okay, now the second problem is Zener diode is on and normal diode is off. If Zener diode is on, then the voltage across this will be 10 volt. Okay, yes or no? If this is on, then we can replace this by a battery, and the voltage here will be 10 volt, and this is 20 volt. Okay, and here you are 10 volt. So what is the voltage here? So this voltage also going across this whole branch. So 10 volt is across this branch. That means this diode still cannot this diode cannot be off. So this should be also on. So if I say this is on, and then this will be also on. Now the next possibility is I say this is on, but this is off. That you have to check. Okay. So if this is on and this is off, then tell me what is the voltage across this branch. Tell me what is the voltage across this branch. So if you want to find the voltage across this branch, you need to find the first current. How much current is flowing in the circuit? Okay. So the total resistance, total battery is 20 volt, and the resistance is 2 kilo ohm, 1 kilo ohm, 3.5 kilo ohm. Okay, tell me what is the current value? 20 divided by 3.5. Tell me what is the value? What is the value? Yes. Yeah, someone mic is on and it's not audible. 20 divided by 3.5, how much will come?
5.7.
5.7, very good. 5.7 milliamps. Okay. Now this is 5.7 milliamps. Now 5 because this is off. Okay. And I'm saying this is on. So now this I can replace by a battery of 0.7 volt. That means now what will happen? This current will flow here, here. Now what is VL now? Okay. Tell me what will be VL. Now this VL will be so now what is the voltage drop across this whole branch? So this is a 1 kilo ohm and this 3 kilo ohm. So this voltage across Zener diode, I say VZ is equal to 3 kilo ohm plus 5 into 5.7 milliamp. Okay, plus 0.7 volt, and this is greater than 10 volt. So if I say this is on, this is off, but then the voltage across the Zener diode is also greater than 10 volt. Okay, so this cannot be off. The only option remaining is both the on. Are you getting this my point? If I say this is on, this automatically becomes on. Okay, both cannot be off. If I say this is on and this is on, if I say this is on, then by calculation I find the voltage across the Zener diode is 10 volts, so that it should be on. So only the option is both the on. So this is the wrong option. Okay, so the only option is both the on, and now you can find what is the voltage VL across this one. Once I say both are on, I can replace this by a battery of 0.7 volt, so 10 volt, 10 volt, and now I can find what is the voltage drop across these here. So I can find the current in this branch. Current in this branch will be, tell me how, 10 minus 0.7 volt, okay, divided by 1 and 3 kilo ohm. This is 9.3 divided by 3 into 10 raised to power 3. Okay, tell me what is the current value of this current? What is the value of this current? 3.3.
3.1 milliamp. 3.1.
3.1 to 10 raised to power 3. Okay, milliamps. Okay, now what is the V load? V load will be 2 kilo ohm into 3.1 to 10 raised to power. So 6.2 volt. Okay, so 6.2 volt is the answer, correct answer for this question. Okay, so this particular question is easy because both the diodes are on, but sometimes you have to check which is on, which is off. So once I say this is on, then this voltage is 10 volt, and this whole 10 volt is coming across this whole branch. Okay, this 10 volt will divide here, 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 and here. So I have calculated the current. Okay, and once I know the current, I can find the voltage here. Okay, is that clear? This question is clear to everyone? Or I need to explain again? Okay, shall I go to next question? So let me go to the next question now. Okay, so what should I do in second question? Can anyone tell me what is the second question? In second question, you have a battery of Zener battery. You are given 35 volts. A 35 volt battery is given. Okay, a resistance R is given here, and you have a Zener diode connected. Two Zener diodes connected, and a resistance R. Okay. So the question asking the question number 42 is question number second of the sheet. The following Zener diode voltage regulator circuit is used to obtain 20 volt regulated output. Okay, at load resistance RL from a 35 volt battery. Okay, Zener diode ratings are given 5 watt and 10 volt. So Zener diode ratings are given 5 volt and 10 volt. So obviously this is RL, okay, RR, R and RL. This is R and RL, okay. Now we have given the power rating and voltage VZ, okay. So VZ for each Zener diode is 10 volt, and PZ max is given. PZ max is given 5 volt. Okay. Once I know PZ max, I can find what is IZ max. IZ max will be your PZ max divided by VZ. So this will be 5 watt, and VZ is your 10 volt. So obviously this become 1.2 ampere. Okay. 1.2, 0.5 ampere. Okay. Now I know the IZ max. How much maximum current can flow through the Zener diode? Okay. So if the current goes more than this one, then this will be destroyed. This will be this Zener diode will be destroyed. Okay. Now he's asking what is the value of R. Okay. So say some value is R, some value have R value is there. So the value is R, and the current is flowing here IZ, and the current is here flowing IL. Okay. Now slowly what will do, I will start reducing this one. So once I reduce this one, what will become the voltage, if I reduce this one, current will increase. Okay. The voltage here is fixed. Here voltage is 20 volt. Here voltage is 35 volt. So voltage by the voltage divider, here voltage is your 15 volt. Now voltage is fixed here, but if I start reducing the value of resistance, what will happen? Current will become, and a particular value, okay, IZ minimum, my current will become here IZ max. Okay, so let us find now what is the value of this R minimum. So I can find my R minimum. Okay, that will be voltage drop here, IR. Say current is here, I, total current is coming IR. Okay, and now this is also variable. Okay, so now R minimum will be, tell me what will be this. This is the V input minus this is total voltage VZ. 2 VZ basically. Okay, so I can directly write 35 minus 20. Okay, and I is your IZ max plus IL. Okay, because IL is fixed now, but RL not given. Now here I can assume that R minimum is series because only I know IZ max. So I can, this is a variable resistance. I can choose a very high resistance and make it 0. So I can just write that my R will be 35 minus 20. IZ max is my 1/2. So this will come how much? 30 ohms. This is 15 and this will come 30 ohm. Okay. So my R minimum cannot be less than 30 ohm. So my R minimum should be either 30 or greater than 30 ohm. If it is below 30 ohm, what will become? That this current will become more than IZ max. Okay. And this diode will burn out, destroyed. Because I am taking the worst case condition, I am taking this condition is very high, so current is almost 0 here. That means all the current which is coming from here going here. Okay, so I am taking, so this current I can be at maximum equal to IZ max. Okay, so when this is IZ max, okay, this should have some minimum value. If this minimum value, if you go beyond this less than value, this diode will burn off. So my R should be greater than and equal to 30 ohm. Is this question is clear to everyone? Pragya, Richa, is there any new students from Vijaya batch? No reply.
Yes, sir.
Okay. So if you still a doubt, you can ask. Okay. If you you do not have clarity about the concept of Zener diode, you can ask me. I will repeat. Okay. Similarly, the third question also is from Zener diode. Okay. Exactly similar type of question. Let us do it. Question number third. Question third means which is the question third of the sheet what I was sent. So here you have been given a 12-volt battery. Okay, a resistance R, a Zener diode, and then you have a variable resistance. Okay, a variable resistance value is given RL, and same question, similar type of question, A, B, and this is your R series. Okay, so in the question they given you P max value 9 volt, same thing. Okay, 9 volt, and they given you P max value connected in the shown figure. The minimum series resistance you have to find out. Okay, again similar question, minimum series resistance. So what is the minimum series resistance? Can tell me now, you can calculate. Tell me what is the minimum series resistance for the question. Same question. This time it is given the value of PZ max. So PZ max is given how much? 0.7 watt. So I can find IZ max. VZ is given how much? 9 volt. And battery is 12 volts. So IZ max will become PZ max divided by VZ. So 27. Yes, tell me how much come? 27 watt, milliwatt or watt, and this is your, you have
30 milliampere.
30 milliampere. Very good. 30 milliampere is the IZ max. Now what is the minimum resistance? Minimum resistance R series resistance minimum. RS minimum will be voltage here. Voltage here will be this minus this is a 9 volt and 0.777 watt. So voltage here will be this voltage minus this voltage, 12 minus 9, and here voltage is IR. I putting RS minimum and I'm putting IZ max. If R is greater than RS minimum, this will be IZ. But if I keep on reducing this one, voltage here is fixed 3 volt. If I keep on reducing, my current will become IZ max here. And this current IL minimum is not given or IL value is not given, so I can choose it to 0. I can make it 0 by increasing this one. So this will be 30 milliampere. So this will be 3 divided by 30 into 10 raised to power minus 3, 1 by 10. So this will come 100 ohm. So is there an option of 100 ohm in the question? So the 100 ohm, the option is the correct answer for this given question. Let us say question number now third. So let us say the question number third. So this question came in TIFR. You have V input. You have a capacitor here. You have a diode here. Okay. You have R value here, and this is your A and B. Okay. And this is your V input here. V input, which is a sine wave from Vm to minus Vm. Okay. So can anyone tell me what is this circuit? Can anyone identify this circuit?
Clamper.
Yes, clamper. Negative or positive? Up or down?
Positive.
Positive. Okay. So always you see, if the capacitor and diode circuit is there, it will be clamping circuit, and clamping will always happen in the direction which makes diode a forward bias. So diode will become forward bias only in this direction. Okay. Sorry. The current can be in the direction current flows. So current can flow only this direction. Okay. So negative side current can flow like this. So the shifting will be up. Okay. Now let us see what happens if when I apply positive cycle. So if I apply positive cycle, tell me what will happen. This diode will be off. Yes or no? This diode will be off. Okay. So current cannot pass from this path, but the possibility is current can come from here to here. Okay. Now if current comes from here to here, this is the load resistance which value is very high, and when the value is very high, most of this voltage will get drop here. So this capacitor will not be charged up to its peak value. Okay, are you getting my point? If I take positive cycle, current can flow from here to here, then the capacitor will charge here from plus to minus, but this is a load resistance which is generally value is very high, so this will not allow the capacitor to charge up to its peak value or V max. Okay, but when we see the negative cycle, in negative cycle, this is plus, this is a minus, and this will make this diode to become a forward bias. So once this diode is forward bias, Now there is no voltage drop in this branch. Okay, so now my capacitor, all the voltage can be drop here. So my capacitor can charge up to minus this up to Vm. The direction is like this. Okay, this is the difference between the charging two sides. So always capacitor charges in the direction flowing in the direction of diode. Okay, if diode conducts, then only it will charge, and this is a final charging direction. Okay, this will not charge like plus minus. Always you see the direction of diode and charge it. Now once it is charged, now this voltage Vm is always greater than this voltage because it's a peak value. So this Vm is always greater than Vm. So what will become this charge that this capacitor will make? Okay, the first thing is your RC time should be greater than time. That is the condition of Clamper. Okay, R is high and R and its multiplication should be greater than time period of the input wave. This should be given in the question, but sometimes they may not give. Okay, but this is the Clamper circuit. Okay, now what will happen? This will charge through this diode in this direction. Now once this is charged, this will become now reverse bias, because now the minus plate is connected to the plus, and this Vm is always greater than V input sine wave. So practically this is now in reverse bias. Okay, because this voltage is higher than current for corresponding to this voltage. Okay, this is a plus, here is a plus, suppose here is a plus 5, and here it is varying from 0 to 5. So practically this is always in the reverse bias. Now I can find what is a V output. So my V output, now I can write here, say, now I can remove this one charge. Now this is my V input is varying from minus to plus. So I can say this is minus V input, okay, and this is my minus Vm, and I'm measuring the voltage like this, plus to minus. So this is plus V naught. I'm applying Kirchhoff law, so this becomes 0. So my V naught will be now V input plus V max. Okay, and now V input is, tell me, is varying like this. Okay, so is varying from negative to positive. Okay, so let us now find what is my output. So this is my input. Okay, and now I'm plotting the output V naught. Okay, when my V input is 0, my output is Vm. And when my input is Vm, my output is 2 Vm. So this become 2 Vm. Okay, like this. And when this is minus Vm, I have a 0 like this. Okay, so you'll draw nicely. So this is my signal, which is clamped on the positive cycle. Okay, so this is the answer. What is the answer? So the answer will be
D.
D. D is the answer. Okay. Let us see now the next question. So this is again Zener diode questions, because I have choose to do a diode. Okay, so most of the questions are coming from the diode. So please, now yes, simple question hai. Now you have to solve, okay, and tell me what is the answer. So the question they're asking, what is the value of Zener current? Okay, it's a new marker and it's not working. So say this is, you have a 40 volts. This is 10 kilo ohm. This is a 40 volt, and here you have 20 kilo ohm, and the VZ is given 20 volt. VZ is 20 volt. Okay. Find the IZ. So you have to find the value of IZ flowing in this. Okay. So first of all, you have to find whether your zener is on or off. How to find whether zener is on or off? Ansh, Aparna, how can we know that this zener is on or off?
रिवर्स बायसिंग।
रिवर्स बायस तो है ही है। अब ये ऑन है कि ऑफ है कैसे पता चलेगा? इसमें ये कंडक्टिंग स्टेट में है कि नॉन कंडक्टिंग स्टेट में है? हाउ टू फाइंड? So we have to find if I want to find what is the voltage coming across this zener diode. Okay, I have to make it open. So I am telling the students which is not on our course. Okay, we always have to make it open, and we have to find the open circuit voltage. If open circuit voltage is equal to or greater than 20 volt, okay, this is zener diode characteristics. Zener diode always works like a normal diode in the forward bias, but in the reverse bias, okay, reverse bias, it works in the reverse breakdown condition. Okay, once it is a conducting state, this is the VZ. So when the voltage, reverse bias voltage become more than the required VZ, then this voltage will across the diode will become fixed. So in order to check whether it is on or off, you have to see how much voltage drop is coming across this zener diode. Okay, so tell me what is V open? V open means across this 2 kilo ohm. So V open, that is here, means here. So 40 volt is total voltage, resistance is total 30 kilo ohm. This gives me the current, and I want the voltage across now this 20 kilo ohm. How much is coming? Tell me, what is the value?
26 point something.
26
26.6.
something. No, so it is, so obviously it is a greater than 20 volt. So that means the zener is on, and once zener is on, I can replace this zener by a 20 volt battery. Okay. So I have washed this board by this soap, so it's coming very light today. I mean, it's still wet. Okay. So now this is 20. Now once I say this is on, I can replace it by battery. Now the voltage will be here 20 ohm. Okay. Now I can find. Now this is just for checking. Okay. Now we have to find what is IZ here. IZ. Okay. Now I know this is the total current I coming here. This is 40, this 20. So voltage drop here is 20 volt. So my total I become how much? Total I become 20 volt divided by 20 volt divide by how much? 10 kilo ohm. Okay. So this will give me how much? Tell me. What is the I? 2 milliampere. Sorry. Okay. This is 2 milliampere. 2 milliampere or 2 ampere is the current value. Okay. Now this I is going here and here. This I is forming IZ plus, if I say this is a load current IL. And now I can find what is the IL, because I know 20 volt is here and 20 kilo ohm is here. So my I load become 20 divided by 20 kilo ohm. So this is 1 milliamps, okay, or 1 milliamp current. And this is minus MP current. So I can find my IZ. My IZ will be I minus IL. This is 2 milliampere. This is the 1. So this is the 1 milliamp answer. So 1 milliampere will be the answer. अब ये क्वेश्चन तो तुमको करके बताना चाहिए था ना. If I do all the questions, how is it possible? So the correct answer is 1 milliampere for this question. Okay. Let us do the next question. Okay. Next question में क्या दिया है? Next question में they have given you equation. So they have given you equation. I equal to I naught one minus V upon V naught square. Okay. So some variation is given. I versus V curve is given. Okay. Now this may be true for any device. Okay. We don't know exactly what is which device is following this one. So some device IV characteristic of some device is given. Okay. Now you say I0 is constant, V0 is constant. Okay. I0 V0 is constant. Now in experiment I measure. I change some device. There is some device. Okay. See some device is X. Okay, some device is X here. And across this X I am applying some voltage, some variable voltage. I'm applying some variable voltage and I'm measuring the current here. So I will be having data. I can plot the data, and once I plot the data, okay, from this data, I want to find how to calculate the I0 and V0 from the graph. Okay. So let us first say write this equation. So I can put it here like root I equals to root I naught 1 minus V upon V naught. I'm taking the root. Now this is the equation of line. If I say this root I, y is equal to root I, okay, and I say v is equal to x, so I can write this is the equation as a y equal to I root, okay, minus I root x upon v naught, where x is v and y is root I. So this is the equation of line y equal to c minus mx. This is a constant, this is the x, and I can say this is slope. So the equation of this line will be what? Decreasing slope, falling slope, minus like this. It will be slope will be like this. Now we have to find the intercept at the x-axis and y-axis. Okay. At x-axis, if I say v equal to v naught, then this becomes 0. So obviously here it will cut at v naught. This is the line equation, and it is cutting at v naught here, x-axis. And the y-axis, x should be 0. If I put 0, so if this x 0, then y-axis it will cut at the under root I naught. Okay. So this is the data I got. These are the data. Okay. यहाँ पे बहुत सारा data है, and then when I merge this data, I find a line. And now I want to measure the experimentally. How can I find these values? Obviously, these values I can find from the graph. This is the I naught and V naught. Okay. So I naught I can find. So the slope of this graph will be how much? Slope of the graph is minus I naught. Someone mic is on. Whose mic is on? So this is slope and this is the y-intercept. So I naught I can find by the y-intercept. Okay, y-intercept will give me I naught under root I naught. And I want to find second thing, I want to find what is V naught. So V naught, how can I find? Tell me. If I want to find V naught, so what I'll take the y-intercept, okay, minus of y-intercept divide by the slope. Slope itself is negative. So minus y-intercept is what? Minus y-intercept is your minus I naught, and the slope is minus I naught upon V naught. So this gives me V naught. Okay. So which is the option?
Option D.
So D is the option, correct option. How can you find these parameters in the laboratory? Okay. Same. Next question is also like the same. It is like a equation type of question. Okay.
Sir,
Let us.
upper part of the board is not much visible.
Okay. Okay. Now.
Sir, the upper part of the board, that V naught formula.
Okay. Just 1 minute. I have to. Okay. Okay. Correct. Just give me 1 minute. Okay. So let us now go for next question. कोई चाय पी रहा है, चम्मच बज रहा है किसी का। हमने तो चाय पिया नहीं अभी तक। Okay, so next question is the IV characteristics of a device can expressed as, okay, again it is given you some equation is given to you, I equals to IS, okay, IS and exponential AVT minus 1, okay, where T is the temperature and A and IS are the constant independent of T and V. Which of the following plots correct for a fixed applied voltage? So applied voltage is fixed. Now can anyone tell me which is the option is
Sir?
correct? Tell me.
Sir, which was the correct option for the last question?
D. So can anyone tell me what is the correct plot for this curve? ये तो तुम कर सकते हो हाँ?
Option D.
Option D. Okay. So the basically you have to plot options are given in the log form. Okay. So say log. So I can say this is log IS plus log exponential AB by T minus 1. Okay. So if I say my AB by T, if my AB by T is greater than 1, okay, then I can write this equation for AB is greater than 1, exponential 1 is 2.7. If it is 2, 3, 4, then I can neglect this 1. So what I can write? I can write log I is equal to log IS. Okay, and this log and exponential will be cancelled. So this will come simply AB by T. So if I say this is my Y, this is my C, and this is simply X. This is a Y plus Y equal to C plus X type of equation for higher value of AB by T. Okay. So this is the, if I plot this curve, can you see this curve? So if I plot this curve by AB by T and log, so for higher value, this is a straight line, okay, with some slope. And if I put AB by T equals to 0, so this term will become, if I put a AB by T equals to 0, then this term become exponential 0, 1 minus 1, 0. Log 0 is how much? Tell me, what is the value of log 0?
minus infinity.
Minus infinity. So this curve will come somewhere here like this. Okay. कौन सा option है?
D.
D is option. Okay. So let us solve now question number 25, IIT JAM again. This is again a question of Zener diode. Okay. करो. Now next question आपको करना है, मैं नहीं कर रहा हूँ. I will just help. The next question is, say, your Zener diode R is given 125 ohm. This is 125 ohm. A Zener diode is given here. Okay, which is 9-volt battery, and IZ max is given. IZ max, you know, that means parameter. PZ max, IZ max is given means, you know, the power, maximum power is 65 milliamps. And here a resistance is given, load resistance, which is 470 ohms RL. And here you have taken the load VL, which is regulated 9-volt. Okay. And this is the V input value. So question, they're saying, what is the maximum and minimum value of V input? Okay, what is the maximum and minimum value of V input? So what is the definition for V minimum? How can I find V minimum? Anshuma, Aparna, how can I find V minimum? What is the V minimum? Can anyone tell me? Shreya?
So that the diode will be in the reverse biased.
Yeah. Anyone other? Okay. So minimum value, see, हमको क्या करना है? We have to make this diode on. So my input should be at least such that this diode is on. Then only it will be regulated. And so this should be a minimum value, and maximum value also should be fixed, because resistance is fixed. If you keep on increasing this one, my current flowing in the diode will be, because here current is fixed. Once this is on, this voltage is fixed, this resistance is fixed, current is fixed here. But now if you're increasing this one, this IZ will increase, keep on increasing, and a particular value of V max and V input, this will become IZ max, that will be V max. If you go beyond this V input max, this will burn. Okay, so there are the limit for V input and V minimum and V max. Okay, so here the limit is V input is can go from V input minimum to V input max. Okay, let us find first V input minimum. Okay, so V input minimum this should be on. So I'll remove this one and find the open circuit voltage, V open or VZ. So V open will be equal to V input minimum upon this 125 plus 470 into 470. Okay, and V open is 9 volt. I want minimum 9 volt. So my V minimum will be 9 into, this is how much? 595 divided by 470. What is the value coming? Tell me.
11.39.
11.3 volts. Okay, 11.3 volt. Okay, this is the definition of V minimum. Now I want V max. Okay, so this is fixed, current here is fixed. Okay, if I'm increasing V max, my current will increase here. So my current will become I max. If I want VI max, then my current I will go to the I max, IR max in the resistance. Okay, so IR max is equal to IZ max plus, here current is fixed because voltage once is on, once it is above the 11.3 volt, this is on, so voltage is fixed here. So current I load is fixed here. Okay, IZ max is given how much? 65 milliamp. 65 milliamp plus IL I can find by how much is the voltage? 9 upon 470. 9 upon 470 will give me the value of IL. Okay. Tell me how much milliampere current is coming. This is in milliampere. Okay. Tell me how much will come in milliampere. This is milliamp. Okay.
Sir, option D is correct.
Yes. This is a milliamp, and this is also come milliamp. How much is coming? It will come around 80 point something. How much is coming?
84.14.
80,
4.14.
81 point something will come. Okay. So once you know the IR max, now you can find, okay, what is the value of VI max. So this is a VI max. So VI max is equal to this voltage. Okay, IR max into R plus, here voltage is fixed VZ. So this voltage is this volt, VZ. So IR max is your 80.14.
Sir, 84.14.
81 point.
84.14.
Okay. जो भी है, okay, you can check it. I don't exactly remember. So 84
Sir, 84.
84
84.14.
84.14. R is 125 and is the milliamps and is the 9 volt. How much will come if you solve this one?
19.5.
19.5. So कौन सा option सही हो गया?
D.
D option is correct. Okay. You can find the minimum and maximum voltage. Okay. So let us take now some 10-minute break. Okay. And then we'll start again. You can have tea. I'm giving you 10-minute break. So we'll meet back. I'll come around 8:45. 8:45 a.m.
So your mic is off.
So I'm saying I will start in 8:45 ना, because वही time दिया था सबको, 3 मिनट बाकी है अभी. So I was saying that if you have any doubt, okay, you can send me your questions. You find difficulty in doing in question, you can send me. I will try to solve. Okay. Okay, let us start. So the next question is, okay, you have been given a circuit, say V input, V input, and this is your R1, B1, and this is your R2, okay, and you want to find V output here. You want to measure V output here at this here, okay, across the diode and the resistance R2. And this is silicon diode, so it requires 0.57 volt to conduct, okay. And this is here the value, this is your R1, and this is V input. So question they're asking, which one of the statements, or which of the following statements are correct, okay. So you have been given V input. Your V input is a sine wave. Your V input is a sine wave. Okay. Your V input is a sine wave. Say Vm2 minus Vm. Okay. So what is the value of V output? Okay. What is the value of V output for positive cycle and negative cycle? Maximum value. बताओ कैसे करेंगे इसको? What will become positive cycle and negative cycle? Tell me how to analyze this circuit. If I'm applying positive cycle, V plus here, V input V plus here, then this diode will become conducting if my voltage is greater than 0.7 volt here. Okay, and this I can replace by a battery. And once this is conducting, this voltage is fixed. The maximum voltage of output, okay, maximum output, what I can get, VP output, which is fixed, I can get 0.7 volt. This battery, this is the whole voltage, and this voltage is getting divided here. So this is your V1 divided by R1 plus R2 into R2. This is the for positive cycle. For positive cycle, this is my V output value, maximum output value. And if I say my negative cycle, for negative cycle, tell me what is my V output? What is the value of V output for negative cycle? Can anyone tell me? If I take positive cycle, obviously for positive cycle, what will become? If my input is greater than 0.7 volt, okay, this diode will conducting and will become replaced by battery. And here the voltage is coming V1 R1 plus R2 into R2. So this voltage plus this voltage is the maximum voltage, which is a fixed voltage. अब कोई ट्रेन में भी घूम रहा है? Okay. So now from negative cycle, what is the V output value? Tell me, Sharlene.
Sir, it will be V1.
It will be V1. Anyone else?
No, V in.
V output will be V input only, na? If now if I take reverse bias minus cycle, this diode will become off. Reverse bias. So once becomes on, this current cannot flow. And if this current cannot flow, here I drop is 0, this will equal to V input. So my V output will become V input. So on the given options, okay, this is not given, it is not given. Only this is given. For positive cycle, this is the maximum output we can get. This is the correct answer. किसी और को डाउट है? मनु, लिप्सा, अपर्णा?
नो सर.
चलिए नेक्स्ट क्वेश्चन पे. Next question is very easy, textbook question. Okay, is given to your every book, and you might have done in your MSc also. क्या ऑप्शन आएगा बताओ? क्वेश्चन नंबर नेक्स्ट क्वेश्चन का. You have a AC source, and here you have a resistance. You have diode here. You have here diode.
Sir, B.
D आएगा. B.
B.
B आएगा. Okay. So you want V output. So this is a sine wave. Okay. V input. For positive cycle, this will be off, and this will be conducting, and I can replace it by battery of 0.7. So positive cycle, you'll get the output equal to 0.7. Okay. Before that, if your V input value is less than, say this diode is D1 and D2. Okay. If V input value is less than 0.7, so this is positive cycle, this is always off. This is always off. And this is also off until you don't achieve 0.7. So then there will be no current. So your V input will be V output. Okay. So this is my V input, and V output up to here, 0.7, my V output will be same like a V input. And after that, once this cross 0.7, this will fix to 0.7 volt. Okay. And again, this follows same thing. Similar things follows in the negative cycle. Negative cycle, this is on, this is off. So this will go like this, like this, like this. Okay. कोई ऐसा है जिसको ये क्वेश्चन समझ में नहीं आया तो वापस रिपीट करूं? इज एनीवन? Positive cycle, this will conduct, this will become 0.7. Negative cycle, this will conduct, so this will become 0.7. So I'm measuring voltage like this. So this is a minus 0.7, minus 0.7. This is a plus 0.7. This is a plus 0.7. This is a plus 0.7. This is a minus 0.7. And if you are whether you are minus or plus, if your voltage is less than 0.7 volt, then this will not conduct. This will not conduct. So you will get current will not flow here. So no current. So whatever voltage is here, that will come here. That's why input is following output up to here, then fix. Okay, again input is following output, and then again it is fix, and then again like this. Let us do the next question. Next question तो मैं नहीं करूँगा. I can't draw this much circuit. Okay, you already done in the class also. So if someone is doubt, you can send me. Otherwise, this is your homework. Okay. The answer will be
ये
what?
वाला क्वेश्चन समझ
नहीं आया समझ में? करना है?
नहीं
चलो करना है तो करो फिर. अब इतना बड़ा बनाना पड़ेगा मेरे को. चलो. So ये आसान क्वेश्चन है. खाली बनाने का दिखाने में ऐसा है. बहुत आसान क्वेश्चन है. This is diode. This is diode. Okay. And this is coming like this. Okay. And then this is here. This here. This here. अरे बाप रे. This is here. Okay. And you have here. Here. Okay. इसको बनाते हैं. देखना कोई मिस्टेक नहीं हो जाए. I am making sure there should be mistake. Okay. And then this is here. Here. This is here. This is here. Okay. And this is here. Here. चेक करो कोई मिस्टेक है क्या यहाँ पर? एक डायोड is here. This is correct. This diode is here. So up to here it is correct. Okay. And now this part, your this diode is coming this one like this. Okay, it's coming like this here. This point, and I'll take this point here. And here you have a diode. Down here is the input. And here one more diode is there. Check, ये सही है क्या सर्किट?
Sir,
और
और
भी कुछ?
resistance है.
एक रेजिस्टेंस और है here. Okay, that's it. So क्वेश्चन बड़ा सिंपल है, इसमें कुछ करना तो है नहीं. आपको दे रखा है you have given a V input. Okay, V input I am giving here, and V input is a sine wave. Okay, now these all diodes are ideal. So when I say that this is a plus for positive cycle, okay, this will be conducting. So this V input this will be short. This is short. Similarly, now this will be also short because current is coming like this now. If it is a positive cycle, my current will flow like this without any loss, and it will go to here, it will go to here, it will go to here. So whatever value is here, V input, same value will come here. So say it is a 0, 1, 2, 3, 4, 5. Here it will also come 0, 2, 1, 2, 3, 4, 4, 5. That means for positive cycle, if this is my input, for positive cycle, my output will follow exactly my input. My output will follow input, because the current will flow like this and without any drop. There's no drop. This voltage and this voltage is same. So I'll get exactly my V output will be exactly like V input. And for next cycle, negative cycle, what will become? This will become plus and this will become minus. Current flow oppositely. Now current, because this will be short circuit, so current will go from here to here, here to here, and then here to here, and then this current will go here to here, and this current will go here to here. Correct? If I had drawn the circuit correctly, okay, then what will become? Sorry, if I'm saying current is starting from here, that current should come here, na? So current is starting from here. So this current will go from here, this side, okay, this side, and this side to, it will go here. So यहाँ से तो शुरू हुआ है, it will go here. And now this current will go, this will be short circuit, okay. This will be open circuit. So if we should come from here to, wait. ये यहाँ पे नेगेटिव है ना, यहाँ पर this negative is there ना.
हाँ
So
sir.
this become open. So this oh sorry, I am plotting wrong. Now this is a plus. So if I'll follow this, not this path. This is the wrong path. I'll follow plus. Okay. If I say minus, then I have to flow here. Now this is the wrong path. So I'll flow plus path. So I'll go from here. Current will go here, and again here too. It will go here. Okay. So if this is here is a plus 5. Suppose minus. So here is a minus 5. Okay. Here it will come plus 5. Suppose here is a minus 1, it will come plus 1 here. It is a minus 5, it will come plus 5 here. It is 0, it's 0. So that means for negative cycle also, I'll get a positive output. Because
Sir,
now,
ये last part repeat करना एक बार.
see, this is your positive part, this is negative part. Okay, negative part. So now current, I mistakenly drawn this path. This is not a path. So path is basically following the positive current. Current will flow from positive to negative. So in positive cycle, your current will go like this, making this short, and this go here, and this go here. Now this is a negative cycle, negative input. So how will I apply? I'll apply -1 volt. So this will be +1 volt. Okay, -1 volt का मतलब क्या है? If it is a 0, is a -1 volt. I can say this, if this is a 0, this is my +1 volt with respect to this one. ये क्या 0 - 1 is a -volt. With respect to this one, this is a -1 volt. So when -1 volt you are giving here you are getting +1 volt. Similarly, if you are giving -2 volt here, okay, that means if it is 0, it is a 2 volt. So 2 volts are coming here. If you're giving peak value here, -5 volt, that is 0, this become +5 volts. So it is coming here +5 volt. Okay, so negative cycle also, the output is the same direction like it is a rectifier, full wave rectifier. Okay, is it clear now? Or shall I explain again? Any confusion? Aparna?
सर वो नीचे सबसे लास्ट वाले डायोड में करंट फ्लो नहीं करेगा?
सबसे लास्ट वाला कौन सा है? ये वाला,
लाइन में
ये वाला। अब करंट तो ये तो ऊपर हो जाएगा ना, बिकॉज द प्लस इज कनेक्टेड टू द प्लस माइनस प्लेट, दिस विल बी ओपन। यहाँ से करंट क्यों फ्लो करेगा? ये तो प्लस है ना, मैं तो प्लस, मैं तो उल्टा चला रहा हूँ ना।
नेगेटिव हाफ साइकिल में हो गया।
हाँ, नेगेटिव हाफ साइकिल में ये तो ये प्लस है, ये करंट यहाँ से आएगा, आपका बैटरी, योर सिग्नल बिकम अपोजिट नाउ. So this will go like this, and this will go like this, and this will come here, and this will come like this. Okay.
Thank you, sir.
Okay. Let us do other problems. So you have been given I not given reverse saturation current. Okay. So basically the ratio of reverse resistance to the forward resistance you have to find for a PN junction. Okay, PN junction. Okay, you all of you know, if you have a PN junction, if you give PN junction is given and you make it forward bias, plus to N. Okay, so a current will flow in forward direction. That current is IF. Okay, and the equation for the current is the IF or I PN junction or I diode. Okay, PN junction diode is given by I naught exponential QV upon eta KT minus 1. You say this is diode current, okay, or junction current, ID. Okay, this is called Shockley equation or diode equation. This is a diode equation or Shockley equation. Okay, now for forward bias, this will become plus. Okay, so forward bias, I will say my ID is equal to IF. Okay, if for forward bias, I say my ID is IF. This is my I naught exponential. I say this is my QBF by eta KT minus 1. And because of forward bias, I can neglect this one because this is the positive quantity. Okay. So I can write my I naught is equal to exponential QBF upon eta KT. This is my current. So forward resistance will be RF. Forward voltage VF. If I'm applying voltage, this is applied voltage, A applied. Okay, so my current, so if I apply voltage here, this will become VF upon IF. IF is your I naught exponential. So I can write exponential minus QVF upon eta KT. This is my forward resistance. Now reverse resistance भी क्या होगा? Reverse, whenever you apply reverse bias here, that is minus here and plus here, then it is a reverse bias, then current flows like this, and that current is reverse saturation current. Okay, so because this applied voltage become negative, and when applied become negative and is very high, this quantity becomes zero. So for reverse bias, I can write for reverse bias. For reverse bias, my I reverse is just equal to minus I naught. It's just equal to minus I naught. Because this applied is negative, the exponential negative, say infinite becomes zero. So ideal come minus I naught. So I reverse will come minus I naught. Now you can find the reverse. You can find the reverse resistance. So reverse resistance will be R reverse R say, okay, VR upon I naught. I am taking resistance value, so I'm not putting the minus. Now the ratio of RR to RF will come VR upon I naught. Okay, V and RF is what? RF is your VF upon I naught exponential minus Q VF upon eta KT. Okay, I naught cancel. So RR RF will come VR VF and this will come exponential Q VF eta KT. चेक करो कोई ऑप्शन नहीं क्या ऐसा वाला? तीनों कोई मिस्टेक तो नहीं हुई ना? ए की बी आएगा? बी है ना? ए कहाँ है? तो पीछा बी आर ऊपर है, ठीक है. वी आर अपॉन वी एफ एक्सपोनेंशियल क्यू एफ, ए ऑप्शन. चेक करो कोई मिस्टेक तो नहीं की मैंने. आई एफ इज करेक्ट, आई एफ इज दिस करेक्ट. So RF is VF upon I naught exponential is negative, correct. For reverse bias, this is like this. RF bar correct. Okay, the option A should be correct. Okay. Shall we go to the next question? Okay. Anshuma is saying hi to everyone. So now let us say
आंसर क्या था सर पिछले वाले क्वेश्चन का?
A.
ओके, थैंक यू सर.
So TFIR 2016. Okay. So you have given a register R with a device X, and here you have a resistance here, and this is your a battery of 2 volt, and this is 100 ohm resistance, and this is also 100 ohm resistance. Okay. Question पूछा है the current voltage characteristics of device given. Okay, determine the current I flowing through the device. How much current is flowing through this device? Means in this branch, how much current is flowing? This is a 2 volt, this is a 2 volt, this is a 2 volt. Okay, and then they have given you the IV characteristics of this device. Okay, and the IV characteristics of this device is given like this. Like this. Okay, so this is your current values. See, like this. These are current values. And current value is given up to what? up to say 20. Say this is 15. Say this is 10. So this is 20. So this is 10. And say half, na? If I say this is 5, this is a 5, then this is a 10, then this is a 10, and then this is a 15, and say this is a 20. Approximately, I'm plotting the curve. Okay, so this is the curve. This is my curve. Okay, and this is the applied voltage. So applied voltage, say here, say here, voltage. Some voltage values are given. Okay, say here, say 0.8, 0.7, 5. You can see the graph, and you can see what is the values given in the actual values given in the graph. Okay. Now this says how much current is flowing through the device. Okay, can anyone tell me how much current is flowing? कैसे निकालेंगे current? Charlene, can you tell me how to find?
Sir, can we find the voltage across that and compare it with the graph?
So how much voltage should come? Okay. So one thing you have to keep in mind, this here is 2 volts, so here also should be 2 volt. And here total volt should be 2 volts. And in order to be total 2 volts, you know, here the current is 2 volt divided by 100. 2 volt divided by 100 has how much? 150. That is 20 milliamp. 20 milliamp current is going here. Okay. But here some device is there which will lose some voltage. So obviously the current will here it will go, which will be less than 20 milliampere. Okay. So here is current is 20 milliamps. Okay. The current will be less than 20 milliamp. Okay. Now you have to find how much the current is there, so that this total should be 2 volts. It should be 2 volts. Suppose if I say that my voltage is 0.5, then how much current is corresponding to 0.5? 9 milliampere. Okay. Suppose if I say this is 0.5 volt. Okay, and I find the voltage correspond to 0.5 volt. This is 9 milliampere. So 0.5 and 9 milliampere flowing here will give you 0.9 volt. So 0.9 volt and 0.5 volt is not 2 volt. That means 9 milliampere current is not flowing. Then I'll go to the next. I'll go to the 1 volt. At 1 volt, how much current is flowing? Tell me. Anyone? By seeing the graph. 14. So if I say this 1 volt and 14 current is flowing here, so 14 volt, and so here current will become how much? Here voltage become 1.4 volt. Yes or no? If I say 14 milliampere current flowing here, so 14 milliampere into 100, this become 1.4 volt. So 1.4 volt and 1 volt here, 2.4 volt cannot be there. Are you getting the point? You cannot have a 0.5 volt, because 0.5 volt will give you the current 9 milliampere and 0.9 volt, and this is 0.5 or 1.4 volt. If you go to 1 volt, this become greater. So somewhere value between these two. So if I say my voltage is 0.8 volt, how much current is from 0.8 volt? See the circuit, see the graph. For 0.8 volt, how much is the current? Agniva.
Sir, is it 12?
Yes, 12. So if I say this is 0.8 volt and this is 12 milliampere, total voltage become how much? 100 into 12 milliampere plus 0.8 volt. This become 1.2 volt, 0 point equal to 2 volt, which is satisfied my equations. Okay. So that means I, what is the value of I flowing in the circuit? The value of I flowing in the circuit is 12 milliamps. So there are sometimes these simple questions also they give just which general thinking. So let us do the next question. Okay. They are given you have a V input. So this is R Zener diode, and you have normal diode here, and this is grounded, and with this respect to the ground you're applying V input here. Okay, and then you have a load here, and you're taking V output here. Okay, so they say the voltage drop across silicon diode is normal diode is 0.7 volt and a Zener diode is 9.1 volt. Okay, for this one you require 9.1 volt, and here you require 0.7 volt. This is a silicon diode and this is Zener diode. Okay, if the input sine wave is a 15, you have to basically plot the output. Okay, here you have an input wave which is 15 volt to minus 15 volt, and for this one you have to plot the output wave. Okay, so this is your input wave, which is plus 15 volt to minus 15 volt, which is input wave. I want to plot the output wave. Now, if this diode, if this path has to conduct, if this whole path has to be conduct, then I require 9.1 volt here, and then I require 0.7 volt here. If I want to conduct in this manner, okay, then I require minimum 9.1 and 0.7, that is 9.8 volt. Okay, if my input is less than 9.8 volt, if my input is less than 9.8 volt, until this path cannot conduct. Okay, and if I want to conduct so this path, if I cannot this I require only 0.7. Okay, so I require only 0.7 volt. Okay, so and once my voltage become greater than 9.8 volt, this voltage become greater than 9.8 volt, obviously the V load will become 9.1 volt, because this is parallel to this one. So once I give the input voltage, that means after this voltage I'm plotting here itself. After this voltage, my output become fixed. Fixed will be 9.1 volt. Okay, so say here only. Okay, so when this is above 9.8 volt, okay, I'll get from here to here for this portion. For this portion, I'll get a fixed output 9.8 volt. Okay, and here the boundary is there. Now what about these portions? What about these portions? क्या होगा this portion पे? In this portion, what is the value? So initially if you want to go from this path, you require at least 0.7 volt here. Okay, so initially some voltage comes 0. Initially also voltage comes 0 is 0. Okay, and then once this is conducting, okay, so input minus 9.7 should come here. Okay, but in the option they asked us to qualitatively. So qualitatively, what you can take for this part, you have constant values, so you can say this is constant, and here you can take 0 values. Okay, here you can take 0 values, this is 0 values, this is 0 values. Okay, and negative cycle, for negative cycle, this diode is open. So current cannot flow. Here to here, anyway, current cannot flow. This is open. So you won't get any current here, you get any output here. That means for whole negative cycle, your current will come like this. Okay, 0 for negative cycle. So this is your, actually it should be like this and something like this here. But option they ask only qualitatively. Okay. So they did not give this part also. So say they only when you have a greater than 9.8 volt this input, here output become fixed to 9.1 volt. Okay. Here. So they are given the option like this. This one, and after if less than this one, that the path is open and you get for an anti-negative cycle, you get a 0 this one. Okay. Now if it is any doubt, any confusion, you can ask me. I can repeat again.
Sir, in the negative cycle, is it that there is no current through the load, that's why we are getting 0?
Yes, no current because this is open.
Okay.
So the battery path cannot be completed, so you'll get 0. So it's coming 0.
Okay, sir.
सर पॉजिटिव पार्ट में 9.1 वोल्ट होगा, आपने 9.8 में
9 पर ये तो इनपुट का है।
ओके
इसके ऊपर जाएगा तो यहाँ पे 9.1 वोल्ट आएगा। पर जो ऑप्शंस what they given like this only. Okay, they are plotting inside the input also, output also they are plotting, and there's a qualitatively approximately what will become. So approximately will become like this. From here to here, and then the 0. This is basically your output wave, what I have drawn here.
ओके सर, थैंक यू सर.
Let us go to the next question. Now I think remaining questions are same. Okay. So I'll go to the question number 4. Okay, this one, because otherwise we're not able to complete all the questions. So tomorrow, if we are not complete, we continue tomorrow. Okay. So this is question number from GATE 2012. So this is 24 volt. This is 12 kilo ohm. This is 6 kilo ohm. And here you have a diode. Okay, of 3.3 kilo ohm. So he's telling in the following circuit, the voltage drop across the diode is followed by this condition is 0.7 volt. The current passing through the diode is. You have to find the current passing through the diode. Okay, how much current is passing through this diode? Okay, and you know the diode is a non-linear device. Okay, you can do this question in many ways, but the best thing is you have to make this branch open. Either you make this branch open. First, you have to find out whether this is open on forward bias or forward bias. Okay, so you have to make this branch open. Okay, and for the simplicity, I am making this branch open. I'll find the Thevenin circuit across this branch. Okay, I'll find the Thevenin circuit across this branch. So VThevenin, what is the VThevenin here? Tell me, what is the VThevenin here for this circuit? I want to draw a equivalent VThevenin.
12 volt.
So this is 24 is getting divided into 12 and 6. So 24 is this is V open and which is equal to VThevenin. So VThevenin will be 24 divided by 12 plus 6, 18 kilo ohm into 6 kilo ohm. So this 6 will go 3 and this will go to 8. So how much? 8 volt. So 8 volt is a VThevenin. Okay. So this circuit is equivalent to what? VThevenin is 8 volt. 8 volt. Okay. Or you say VThevenin, which is 8 volt. What is RThevenin? What is RThevenin for the circuit? I am putting equivalent graph. In order to get RThevenin, what will do? I'll do short circuit this. I will deactivate independent source. Now what is the RThevenin across this open terminal? This is common terminal. This is the common terminal. So these two resistors become in parallel. So my RThevenin become how much? 6 into 12
4 kilo.
into 18. 3, 4. So 4 kilo ohm. So this become 4 kilo ohm. And now I have removed the diode and I have removed a 3.3 kilo ohm resistor. Okay. 3.3 kilo ohm. So open circuit I am plotting again things. Now this is 8 volt. This requires 0.7 volts. So obviously this is making this diode as a forward bias. So this forward bias, this can be replaced by a battery. Okay, now I can find how much current is flowing through the diode. So the ID will be what? ID will be 8 minus 0.7. Out of 8, 0.7 is consumed here, 0.7. And remaining goes to the resistor. Resistor is how much? 7.7 kilo ohm. Okay, you can write the KVL. You know how to write the KVL? Minus 8 plus I into 4 kilo ohm plus 0.7 into I 0.7 plus 3.3 into I equals to 0 kilo ohm equals to 0. And from there, you can find the ID. How much is coming? This is how much? 7.3. Correct? 7.3. And this is how much? This is also 7.3.
0.94 milliampere.
No, this is also 7.3, na? 7.3, 7.3. So this is come 1 milliampere. Answer is 1 milliampere. Okay. Now this is next question is Zener diode. Okay. We have done a few questions like this. So this is your homework. You have to send me this question. Do you want me to do this, or you can do it? Tell me by seeing this question. I hope you can do it. And the question number, next question also Zener diode. RS max you can find out. Okay. Then this is your, and this next question is from Clamper. This also you can do it. So I'll do now the question from say IIT JAM 2014 question. I will do that one. जो भी questions, which are questions I am not doing here, that is your homework. Okay. So say IIT JAM 2014 question. IIT JAM 2014 question. Okay. So you have say here a 1 kilo ohm resistance. Okay. And here a diode which is given a voltage 3 volt, and you have a V input here. V input is sine wave, and you have to find what is the V output. Okay, this is a 1 kilo ohm. So this is a sine wave. Okay, basically it is given like input is given like this. It's a sine wave. And now you have to find the V output. This is your V input. Tell me what is V output? कितना होगा? What should be the curve for this one? Anyone?
Sir, option D.
Option D. बताओ कैसे प्रोसीजर बताओ कैसे? Option D तो मुझे पता नहीं क्या. What is the procedure?
Sir, up to when Vin become up to 3 volt, that will not be conducting, so Vin will be the output. If it
Yes.
is more than the 3 volt, then it will be conducting, so
Yeah.
we will get
Yes.
3 volt.
So for positive cycle, if it is more than 3 volt, it will be conducting. And once it's become conducting, okay, this becomes short circuit. So this output will become equal to 3 volt. Yes, okay, like this only. So this will be like this for positive cycle. Okay, and then this will come like this for negative cycle. For negative side,
It
will
will be
go-
reverse biased always.
so it will be open. So no current will flow. So this voltage will directly come here. So V output will be equal to V input. So curve will come like this, something like this. Okay, you can do plot nice way, symmetric way. So here will be out. What about questions? Next question from IIT Gen 2017. It is slightly changed. So you have a circuit. This is your R. This is your diode. This is your diode. This is your R. D2, D1, R. And here you have a P and Q. Okay. And input is 2 volt battery. Input is सारे क्वेश्चन तो सेम ही तरह के आते हैं यहाँ पे. Okay, nothing new is coming. You will see throughout all 20 years questions. Okay, little bit variation is there. Now these diodes are silicon diodes. Okay, 0.7 volt. Silicon diode. Okay, question is given a silicon diode. So for positive cycle, I have to draw the diagram now. Input. So input wave is like this. Okay. And this is my output wave. This is my input wave. For positive cycle, D2 is always off. D2 is always off for positive cycle. And this can become on up to 0.7 volt. So obviously when this is above 0.7 volt, you'll get like this curve of a positive cycle. Positive cycle up to here, you get like this, and then you get like this. Tell me what will become negative cycle? Negative cycle, I will get same thing or more or greater than this one. What will become negative cycle? Tell me.
It will be greater because there is a voltage drop across R also.
Yes, In negative cycle, this become forward bias, so this become this will become 0.7 volt. But current is flowing, so out of maximum 2 volts, when peak value is 2 volt, 0.7 is here, 1.4 will go here. So 1.4 means 0.7 here, 0.7 here. So the maximum output will go up to 1.4 volt. Okay, so it will get more than this one, more than this one. Because now voltage drop here also will be there. Here plus minus 0.7 volt. So this sum will come like this. This option. Okay. Now I gave some question in the Vijay batch. Okay. I'll like to do that also, so that those students also get benefited. So the question is, you have been given a diode, okay, with 9 volt battery. So you have a diode,
सर
and
आंसर क्या था सर पिछले क्वेश्चन का?
पिछले क्वेश्चन का आंसर था C.
थैंक यू सर.
So this is a 9 volt battery. Okay, and this is your this one 1 mega ohm resistor is given. Okay, and this is the plus, this is the minus. Okay, so question में he's given that the diode in the circuit of figure is a large high current device whose reverse leakage current is reasonably independent of voltage. So leakage current flowing in the resistor, of course, this diode is reverse bias, so some reverse saturation current will flow. Whenever diode is reverse bias, leakage current will flow. Okay, reverse saturation current, that is independent of this voltage drop here. Okay, and if V were equal to 1 volt but this current is always dependent on temperature, and it becomes twice every 10 degrees centigrade increase. In general, any reverse saturation current become doubles, okay, for increase of temperature 10 degrees centigrade. Okay, so the question is saying volt, if V is equal to 1 volt at 20 degrees centigrade, find the value of V at 40 and 0 degrees centigrade. So you have been given the value of V is equal to 1 volt here, okay, at 20 degrees centigrade. So value is given 1 volt, resistance is 1 mega ohm. That means some current is flowing here, that is reverse saturation current, and this reverse saturation current is making at 20 degrees centigrade. This value is IS 20. Okay, so what is IS 20? IS 20 degrees centigrade. What is the value? This will be this voltage 1 volt divided by resistor 1 mega ohm. So this will become how much? This will become microampere. Okay, 1 microampere current, reverse saturation current is flowing at 20 degrees centigrade. Now it is asking what is the value at how much? 40 degrees. What is the value of reverse saturation current at the 40? What is the voltage at 40? So I have to find what is the current at 40. So IS at 40 degree centigrade. Okay. What is the formula? Tell me. Every 10 degree increase, it will become twice. So if I want to find at IS at 30 degrees centigrade, my current will become 2 into IS of 20 degrees centigrade, which is 2 microampere. Similarly, if I want to make IS 40 degrees centigrade, it will be twice of 30, IS 30 degrees centigrade. So this become now 2 to 2, 4 microampere. So now 4 microampere current is flowing at this temperature. Okay, so voltage will be here 4 volt. So voltage will be 1 mega ohm current into IS into this one. So IS is 4 microampere and the resistance is 1 mega ohm. So voltage become 4 volt. Okay, so at 40 degrees centigrade, the voltage is 4 volt. Similarly, at 0, what will become? Tell me what 0, what is the IS? If I go to 0, 20 to 0, so IS 10 degree centigrade will be half of this one. That will be 0.5 microampere. And if I go 10 less than 10 more, 10 less than more, then IS at 0 degree centigrade will be 0.25 microampere. So obviously now voltage will be how much? 1 mega ohm into 0.25 microampere, that is how much? 0.5 ohm at 0 degrees centigrade. This should be the answer.
Sir, can you explain how you find out the current once again?
Yeah, 1 minute. Let me check the answer first. Yeah, correct. Okay. So in the question, this says at 20 degrees centigrade, the output voltage here is 1 volt. Okay. Now, if this is the 1 volt, okay, obviously some current is flowing here, which is nothing. This is a reverse saturation current coming here, opposite negative to positive plate. And this current is flowing here. So I know the voltage, I know the resistor. I can find the current. What is the current at 20 degrees centigrade? Because the current here itself is the reverse saturation current, na?
Sir, that is fine. My confusion is about that 2 times IS will rise when there is a 10 degree.
So this formula we have discussed in the class, na? That IS2, okay, is equal to IS1 twice T2 minus T1 by 10 divided by 10. So if you have a, say, this is temperature T2, IS2 at T2, and this IS1 is at T1. So if you know the current, some temperature T1, and if you increase 10 times, difference is 10 times. Just like this is 10 degree, this is 20 degree. Difference become how much? 10. 10 divided by 10, this becomes 2 power 1. So this becomes double. So every increase of 10 Kelvin, your reverse saturation current becomes, reverse saturation current is the actually function of temperature. Okay, while discussing the theory, I told in the class also that if you plot the curve I versus VD for a diode, this is the forward characteristics and this is my reverse characteristics. Okay, and this is IS saturation, and this IS saturation is at suppose this is at temperature T1, this curve is at temperature T1, this is at T1. If I want to make T2, so T2 this will come like this. T2 will, this built-in potential will decrease, but here current will increase. Here current will become like this. And if it is a avalanche breakdown, then this will also increase. Avalanche breakdown, this voltage will also increase. If I temperature T3, this will reduce further and current will reduce here and this will go to like this. So my current, this current becomes always doubles. If the temperature difference is greater than 10 Kelvin, so I have 10 Kelvin current become double. So from that I have calculated this one. Okay.
Okay, sir. Thank you.
अरे भाई ये कौन सा तमिल है, तेलुगु है, क्या है, केरला है, कौन सी लैंग्वेज है? Which language? Okay. Next question. Okay. Now this is the same question, similar type of question. Okay, you say using the fact that a silicon diode has a reverse saturation current 10 to the power minus 14 ampere. Okay, you have been given reverse saturation current is 10 raised to power minus 14 ampere at 25 degrees centigrade. 25 degree centigrade. Okay. And this says now my reverse saturation current increases by 15%. By 15% for 1 degree centigrade rise. I told for 10 degrees centigrade rise, it's become doubles. That's general case. But now is this says that current increases by 15% for each 1 degree centigrade. In general, current increases by 7.5% for 1 degree centigrade. But in this question, they given some opposite values. They say current increases by 15% for 1 degree centigrade in rise. Okay. So find the value of IS at 125 degrees centigrade. Okay. So this is 25. This is you to find IS value at 125 degrees centigrade. Okay. So suppose I want to find the current. Now I want to find the current at 125 degrees centigrade. Okay. So this current is 15% more than the current at 124 degrees centigrade. Yes or no? 15% more than, that means I have to add 1 plus 0.15. Okay. IS 125 is 15% more than I124. That means I24 plus 0.15 of I24. Okay. Similarly, if I want to write IS 124 degrees centigrade, then I can write again same like 1 plus 0.15 of IS 123 degrees centigrade. Yes or no? No. If I want I5, this like this. Okay. Now same thing. I can write here. I can keep this 1 point. This is 1.15. I can keep like this. I can say IS. This will be equal to 1.15 into IS of 120 degrees centigrade. Like I have written I5 like this here. I4. I can write I124 same like this. Okay. So if I keep on writing like this, 122, 121, okay. So this power will be keep on increasing. This power will keep on increasing and this become 1.15 power 100 into IS at 25 degrees centigrade. And 25 degrees centigrade current is given 10 to the power minus 14. So 1.15 into 100 into 10 to the power minus 14 ampere. 1.15 का पावर 100 कितना आएगा बताओ, कैलकुलेटर से निकाल के बताओ कितना आएगा. How much will come? That will be the answer. 1.15 की power 100 is how much?
One 1.17 into 10 to the power 6.
Yes. So 1.17 to 10 to the power minus
Plus
6.
6.
Plus 6. And this is 10 to the power minus 14. So how much will come? 1.17 into 10 to the power minus 8 ampere. This is the answer. Okay. Next question, one more question we'll do and then we'll continue tomorrow. One more question we'll do it. Okay. So is it clear to everyone? Shalin? Is it okay? So next question is what? Next question says consider a silicon diode with N equal to 1.5. So you have a N equal to 1.5 eta silicon diode. And generally silicon diode, okay, eta is given, okay. So find the change in voltage if the current changes from 0.1 to 10 milliampere, okay. So this is your current. What is the equation of current? Tell me. What is the equation of current? Diode equation. ID equal to IS exponential Q V upon eta KT. Okay. Minus 1. This is the diode equation. And now what is given in the question? You have to find the voltage if current changes from 0.1 milliampere to 10 milliampere. So we have to assume that is this is the forward bias because current is given in milliampere. So I can say ID equal to IS exponential QV eta KT. Okay, and temperature is given or not in the question? Temperature also not given. So other things are same. Eta is 1.5. Now you are given the current value. Current value is 0.1 milliampere. This is 0.1 milliampere. Okay. So you find say ID1, say ID1 equals to ID2. So it is ID1, say voltage V1, and ID2 say voltage V2. Okay. Everything's the same. So now what will come? ID2 upon ID1. No. Tell me how can we solve this problem? Can anyone tell me? How can we find the problem? Okay, so this value is already given 10 milliampere. Okay. So only I want V2, IS is not given. How can I find IS? Tell me. What is the value of applied voltage 0.7 volt for silicon? Tell me, how should I do this problem? Anyone?
सर अगर रेशियो ले लेंगे तो IS तो कट जाएगा.
IS तो कट जाएगा, लेकिन फिर वो वोल्टेज कैसे निकलेगा?
तो दोनों
voltage की जगह सर
एक्सपोनेंशियल है तो हम अगर जैसे डिवाइड में है
अच्छा
तो
अच्छा
V1 माइनस V2 हो जाएगा.
हमको V2 माइनस V1 चाहिए ना? ओके
यस
ओके,
सर.
yes sir.
वो तो हो जाएगा. तो ऐसे निकाल देंगे. निकालो, बताओ कितना आ रहा है. 10 milliampere point 0.1 milliamps. Okay, so exponential QV2 upon eta KT. Okay, so तो कॉमन हो जाएगा Q eta KT, तो कॉमन निकाल लो V2 minus V1. Okay, and this point milliampere points 100. This become 100. Exponential will become log ln 100. Okay, and you want V2 minus V1. This will come eta KT upon Q. And eta KT को generally how can you take KT by Q? Can take 25 millivolts. Okay, and it's 1.5. So 1.5. You say this is 25 millivolt. KT by Q is volt. Okay, and generally this is 26 or 25 millivolts. Okay, so take 25 millivolt. And log 100 कितना होता है? Log 100
4.6.
4.6. How much is coming? कितना आ रहा है आंसर भाई?
172.6.
172.6 मिलीवोल्ट है, 176.2 मिलीवोल्ट। तो आंसर दे रखा है, ये आंसर दे रखा है आंसर उसमें।
Sir, 172 points.
हाँ अच्छा, पॉइंट,
6 आ रहा है, तो यहाँ पे 0.5 दे रखा है.
चलो ठीक है, तो अप्रोक्सीमेटली सेम सेम आ रहा है। वो यहाँ पे 26 वोल्ट ले सकते हैं, 25 भी ले सकते हैं। ओके, so accordingly you can solve. So I'll stop here. I'll continue tomorrow with transistor problem and remaining problem of this here, this thing and transistor problem. Tomorrow we'll continue. Okay, so I'll stop here. Thank you.